So climate change is possibly the major threat that planet Earth has experienced and will be experiencing in this century. It has potential catastrophic consequences. As the planet warms, the changing weather patterns is affecting the microbial ecology of the planet in such a manner that humans are facing new health threats, including emerging infectious diseases and facing a species of organisms that are affecting humans that are more likely to survive these new climate conditions and particularly resist the clinically useful antibiotics. Unfortunately, with this doomsday introduction, I want to welcome you to Editors in Conversation. These objectives of this podcast is to discuss the global threat of the global threat of global warming, elaborate on climate change and changes in microbial ecology, and reflecting the consequences of climate change and the emergence of new infectious diseases and antimicrobial resistant patterns in our pathogens. This episode is brought to you by Antimicrobial Agents and Chemotherapy, available at asm.org/AAC. I am your host, Cesar Arias, Editor-in-Chief of AAC. This podcast is supported by the American Society for Microbiology, which publishes AAC. And if you plan to publish in AAC or any other ASM journal, ASM members get up to 50% off publishing fees. Visit asm.org/membership to sign up. Don't forget our latest issue of AACs with phenomenal papers in microbiology, pharmacology, antimicrobial agents, epidemiology, and clinical therapeutics of antibiotics, among others. We also have collections there that you can access easily on our website with papers in antimicrobial resistance, new perspective antimicrobial agents that are really outstanding reviews, and now our new section on antimicrobial stewardship. I am really delighted today with our guest. It's an honor to introduce Dr. Arturo Casadevall, who is the Bloomberg Distinguished Professor, Alfred and Jill Sommer Professor, and Chair of the Department of Molecular Microbiology and Immunology at the Johns Hopkins Bloomberg School of Public Health. He's also the Editor-in-Chief of MBio and a member of the National Academy of Science. Bienvenido, Arturo. It's a pleasure and an honor.
Muchas gracias, Cesar. It's an honor for me to be here.
So you've been thinking a lot about climate change and have written about. Why don't you tell us our perspective? I've heard you in ASN Microbe, a really wonderful climate change symposium, and a lot of information there. What is your perspective of climate change and how it is affecting the microbial ecology?
So temperature, Cesar, is an extensive variable. What it means is that it affects everything on the cell, from the fluidity of the membranes to the reactions. It enters into all the chemical reactions as delta G equals minus delta H T minus multiplied by T delta S. So what you can imagine is you change things 1 degree, you change everything in the cell from DNA replication to membrane fluidity. So in a warming world, everything will change.
And people think that small changes in temperature, that 1 or 2 degrees, which are not a big deal. But at the molecular levels, those changes in temperature makes a huge difference and probably very important evolution changes. And microbes do this. How can you explain that to the people in general?
So what I would say to people is, they say, Arturo, the world has warmed up maybe 1 degree centigrade, or maybe 1.5 degrees. It's just not that big. I said, no, that you're not thinking about it right. You got to think about extreme days. Every day in which the temperature goes over 100 degrees Fahrenheit, think of that about a selection event. The soils are getting warmer, the sidewalks are getting warmer, all these organisms are being subjected to tremendous stress. And they are learning to survive thermal stress. Stress is stress. So you can imagine that some of these adaptations will not only make them more able to grow at higher temperatures, but will allow them to survive other stress, such as antimicrobial therapy.
Yeah, and with that, you've written about, and actually a long time ago by now, about how the adaptability of certain organisms, particularly fungal organisms, and I'm going to go with the emergence of Candida auris as a very important example that you've written about. And this organism that now is really a urgent public health threat that we are seeing in our hospitals more and more again, and how this emerged as the global warm and the planet continues to warm. There is an affinity for and the possibility for these organisms to emerge. Tell us about your views on
So,
this.
so the story begins in the late 2008, 2009, where we did a study, a very low-tech study, by the way, with Vincent Robert in Europe, in which he's a bioinformatic expert, and what he did is he went to a fungal collection and he looked at the maximal temperature of the isolates. So whenever you put an isolate in a fungal collection, they do a temperature range. And what he noticed was that the majority of the isolates grew very well at 30 degrees. But between the 30 degrees and 42 degrees, there is a rapid drop in viability, such that for every degree in that range, you knock off about 6% of fungal species. That suggested that a lot of the resistance that we have to the fungal kingdom is coming from our temperature. The majority of organisms simply cannot grow at 37 degrees. But that raises another problem. If in fact we're keeping them out with our temperature, what would happen if they adapt and they're able then to jump over our thermal barrier? So in 2010, we wrote an essay in MBio in which we suggested that if this kept going, that there may be new fungal diseases emerging. And it turns out that there was one right over the horizon, which was Candida auris. Candida auris appears simultaneously in 3 continents in 2011, 2012, and 2013. Give me the common denominator between India, South America, and Africa. Give me a common denominator. And also, these strains are not related. It's not like somebody took a plane and moved them around. The only thing I can think of, the common denominator is the world is getting warmer. This organism was out there, loaded, and slowly made the transition to be able to survive in human temperatures, and then we begin to get a lot of it.
So this is a fascinating story, and you see how this is happening. And I'm thinking about the emergence of other fungal pathogens, particularly molds, with the relationship on the environment, the pesticides, for example, and global warming, right? So would you expect to have more emerging fungal pathogens that are multi-drug resistant when you combine all these factors?
Yes. One of the things that is not well recognized is that a lot of the fungi in the environment are naturally resistant to the polyenes, amphotericin B, to the echinocandins, and to the azoles. Many of these organisms are simply not in our radar screen because they can't grow at our temperatures. But if you were to adapt them to that, and they will be loaded, for example, if some of them are pathogenic to cold-blooded animals or to plants, that means that they already have the capacity to evade like innate immunity, and in the case of the vertebrates, adaptive immunity. So that would pose, I think, a significant danger to us. And to me, there is just not that big a surprise that Candida auris was already relatively resistant to our antifungal agents.
Yeah, absolutely. There are very nice studies done by Jerry Wright and others that show that antimicrobials, including antibiotics, I'm talking about mostly in the bacterial world, have been produced ancient. He went to the permafrost, and now all these genes to produce antibiotics are present there.
Right.
So all these organisms have been adapted to all these chemical moieties for a long time. So I mean, resistance was never a surprise, really. But now you combine that evolution that we are using massive amount of antimicrobials with climate change, and we have this monster emerging, right? And that's the most vulnerable patients are the ones that eventually get that. So, what kind of what kind of approach you think we need to think about closer to try to decrease the tide of all these problems?
So the one thing I would say is that even though I've been focused on fungal diseases, the same rationale should apply to bacterial diseases. We don't have a lot of information, in contrast to the fungi, on what is the thermal susceptibility, for example, of things out there. And it may even apply to viral diseases for example, viruses that are adapted to ectothermic or cold-blooded animals. The cold-blooded animals have to make it to 100-degree day too. So even though the warning was about fungi, there is a bigger warning here, and it should affect pretty much everything. But I think the bigger thing to think about is that heat is a stress. Antimicrobials are a stress. Immune defenses are a stress. So we need to be thinking about adaptations to stress that may surprise us in other ways, that it may manifest itself as greater virulence, for example. If you survive heat stress, you might be able to survive oxidative burst better, because you're really talking about common microbial mechanisms of surviving stress.
And we've been studying a lot of stress and, for example, cell envelope stress in bacteria that responds to very common ways in which antibiotics actually act in these organisms. But I live in Houston, Texas, which is particularly not a cold place. And I come from a high altitude place in the Andes in Colombia, which I was not used. But I can tell you, in the last 20 years that I've been here, I've been okay. This year, I've never experienced the amount of sustained heat that we sustained this year. And you see the news, for example, as you mentioned, malaria now is being detected in Florida, Texas.
Maryland.
The arboviruses now, we have in the United States now cases transmitted with no history of travel. That emphasizes your point on this. So what do you think public health authorities can
I didn't
push for
answer
this?
your last question. This is what I think we should do. I think the first thing is research that it doesn't often get a lot of support. We need to sample the natural world. We need to know what's out there. And we need to see, we don't have a lot of information about organisms that cause disease in animals, in wild animals and things like that. In particular, that's the first thing we ought to do. The second thing we ought to do is we need to emphasize basic research on stress and all types of stress of this organism. When you inhale an organism that is used to ambient temperature, and it has the capacity to live at your temperature, think about the stress of going from like 25 degrees to 37. That you have to turn on a lot of stuff to be able to survive and replicate. That, in my mind, is an unexplored target for antimicrobial therapy. The ability to rapidly turn on the stress mechanisms for temperature.
Absolutely. That's so. How do you convince agency to support this research?
Well, I come on your podcast. I think that ultimately agencies respond to what is needed, and if you convince people that this needs to be done, I believe that they're reasonable. These are reasonable things. We need to know what's out there. Candida auris was discovered in the environment, for example, 2 years ago after a lot of sampling in the Indian subcontinent. It was discovered in the Andaman Islands, so it was also reported in MBio. And the interesting thing is it was discovered in two places, on a beach that is frequented by people and on a wild area that people don't go to, which is a marsh. The organism from the marsh was not as temperature adapted as the ones from the beach. And exactly, so it'd be wonderful to go out there to get and try to understand what happened. How do you, what are the adaptations? What are things that we can target for antimicrobial therapy?
So the other thing that I want you to comment on is not the actual organism that cause disease, but the vectors that they
Right.
where they fly on. There is a big story today in the press, which I think is making aware of the spread and the rebound of malaria in Africa due to a spread of different species of mosquitoes in areas that they never seen, particularly urban areas in Africa now having malaria, which they never had due to the spread of different species of mosquito capable. These vectors have this ability to adapt, and mosquitoes have adapted, for example, to insecticides and all that. And then if they can eat in the rural areas, they have moved to urban areas, fueled by these temperatures in a manner. What are your thoughts on
That's right.
this?
I mean, in the 20th century, we made tremendous progress, and it's allowed us a lot of these diseases. And then we began to lose ground through antimicrobial resistance. What I'm arguing is that we're going to lose a lot more ground now through climate change, because the climate change, these vectors are moving into these areas. In these areas, the hosts don't have necessarily immunity. And so you're changing a bunch of variables at the same time, and they're being changed in the negative direction between antimicrobials increased antimicrobial resistance, new vectors in areas, and bringing in additional organisms that were not there previously. So the problems are only multiplying.
Yeah. So for physicians and people who are dealing with disease, particularly in infectious diseases, the familiarity with the infectious disease becomes important when you are diagnosing these things. Um, there's an example of that I wanted to bring up about Vibrio infections, particularly those caused by Vibrio vulnificus.
Right.
So here in Texas, we see this, quite regularly. It's not uncommon, particularly in patients that are cirrhotic, that go to the beach in Galveston and have a little a small cut and with seawater contaminated, and then end up with tremendous soft tissue infections, sepsis, etc. Or they ingest it through oysters here, to the point that restaurants here in Houston, Texas have warnings about that. But then there was a story in the Northeast.
That's
that
right.
There were more patients now that initially were very surprising to see that, right? As the oceans warm, all these sort of tropical diseases are heading their way where you live and
That's right.
in other areas. So, not only from the scientific level, from the clinical level, I think people need to be more aware of all these situations. And what are your thoughts on this?
First of all, I completely agree. I think that the changes we just had malaria in Maryland for the first time in more than a half a century. And I heard about the cases of soft tissue infection of Vibrios in the Northeast. I mean, we have them here because of the Chesapeake Bay. But what you would think, right, that there ought to be a yearly in-service for people to think about these things, because they will begin to happen in your area, even though there has been no experience there. So things are really changing, and I think that this has to become part of our continuing medical education. The climate change update. What is happening in your
Yeah.
area?
From the other aspects I worry a lot is pathogens in the food chain. So we talk about Vibrio, but Salmonella, Shigella, Campylobacter, that seem to thrive. And there is a very nice study done a few years ago where it indicated that about 58% of common pathogens of human beings are getting worse with climate change. There were at 18% that they seem to be declined. So there are definitely some evolution changes in certain organisms. But these particular pathogens that thrive in higher weather conditions, and respiratory pathogen, for example, the Legionella, where is waterborne in air conditioning, and all that depends of all of this climate. So would that mean that we need to think about, in a more broader sense, in terms of policies, how to do public health sanitation, water sanitation, and of course in certain areas of the world when this is worse?
Absolutely, and you probably will have to bring in different strategies. What one of the points I want to make is how I began this thing. When you acquire resistance to higher temperatures, you're changing a lot of things. We don't often think, for example, that the Campylobacter, the Shigella, the Salmonella, they are already adapted to our temperature. They are already human pathogens. But what happens if one of these isolates, for example, as a result of climate change, has acquired the capacity to survive at a much higher temperature? Does that capacity also give it a greater capacity to survive in a macrophage? And the relationship between temperature and virulence is something that is a black box currently. It's not really been explored, but I think it's reasonable to think that if you become more adapted to stress, these organisms will tolerate other stresses. And if you tolerate more stress from the immune system, that could translate into increased virulence.
Yeah. And it's interesting that you mentioned that, because toxin in bacteria, certain toxins, have direct relationship with temperatures and as a stress mechanism so it's absolutely fascinating. Um, the last aspect I want to touch upon here is the issue of equity and balance. Um, Climate change is definitely affecting the world in different manners.
Right.
And with the developing countries probably being more affected, where almost all these diseases are emerging, and as we just experienced what that means, that the spread of these diseases, um, and potentially in developed countries there may be strategies, but how can we make a plea for this inequity in developing countries where these problems are multiplied by millions?
One of the great inequities, right, is that most of the carbon in the atmosphere has been put there by developed countries, right? I mean, since the Industrial Revolution, most of it has been put there by developed countries, almost by definition. Yet it is having tremendous deleterious effects on some of the regions of the world that are least able to handle it because of their infrastructure, their poverty, and their resources. I believe in one world. I think that whatever happens in one part of the world will affect the others. So I would say that the rich countries, we all have a responsibility to try to ameliorate disease and to try to ameliorate the consequences of climate change wherever it is happening. Not only because of responsibility, but also because history shows that what happens, that the infectious diseases are global. So if something happens in one region, it's going to have big impacts in others. So I would argue that we need to increasingly developing more and more a global responsibility. This is one planet that we live in, and we got to take care of each other.
Right. And just as a futuristic thought, um, the situation doesn't look good for human beings at the moment for many reasons. Um, do you think there is a way back, or is
I'm an optimist. I'm an
okay?
optimist.
I would
And
love to hear that now.
yeah, I'm an optimist, Cesar. Imagine that we have had an industrial revolution without a scientific revolution. It's totally possible. I mean, in fact, the steam engine was developed even before thermodynamics. So you could have imagined that humanity could have industrialized and could have triggered climate change without having the concomitant knowledge to understand what was happening, or the concomitant knowledge to develop alternatives. I think we are in a tough space, but I also think that, science is our best insurance policy. I think that humanity has the capacity to, I'm going to give you a scenario, an optimistic scenario that you could imagine a new controversy, let's say 50, 60 years from now. Imagine that we develop the technologies to get the carbon out of the atmosphere, which are now nascent technologies. Where would you set the carbon? You could imagine a world in which people would then be arguing, don't bring it too low because it'll get too cold again. I like to think that we will find a way to set the thing. I think that we are a remarkable species. I think that we are aware of what's going on. I think we have the tools to understand the climate change, and we have the tools to both ameliorate and possibly by the end of the century reverse it.
I love that optimism. My view of that is that as we are creative and as you mentioned, innovative, there are a lot of us on the other side, which are blindsided to this problem, and have the ability to derail most of these initiatives, right? And we've seen it with this pandemic, how that affects and eventually causes deaths and all this. And how can you bring these people to the front? When I say you say trust science, which is absolutely something that I endorse 100%. But why they don't even believe in science? How do you address that?
I think you have to address it one at a time. I think you address it when you go out to dinner with people that may not be. But I would say to you, the only thing that worked during the COVID-19 pandemic was science. Science delivered. Within 1 year, you had vaccines, you had antivirals, you had antibodies, you had rapid tests. This was the result of investments that society made in previous decades that allow a very rapid response. And the continued investment today is our best insurance policy to make it at it. I hear you. I understand that there are anti-science movements. I understand there's a lot of skepticism. But I think that I don't think that putting out statements or anything like that is the way to do it. I think that us scientists need to do this one at a time, need to engage people, try to tell them, I already had 5 shots. I'm looking forward to my 6th shot. These vaccines are safe, effective, and the same thing for all the other aspects of the problems that we're seeing. You try to explain why climate is changing. I'm an optimist, and I think that actually most people are good, and most people want to do the right thing.
And with that thought, I'm going to close it out. I love the optimism. I am, as you know, I'm a Latin, and I love to be optimistic. And I think humanity has a future, and I hope that we continue to trust science and keep working for that. Thank you, Arturo. This is a fascinating conversation. I really appreciate that. This is Cesar Arias, Editor-in-Chief of AAC, signing off.
Thank you, Cesar.